Hello everyone, welcome to Vyas Edification Kota. In this session, we are going to discuss NCERT and exercise solutions of class 11 chapter number 2 units and measurement. Clear? So, in this session, we will find detailed video solution of each and every question of and exercise, as well as here you will find some key concept that is behind that question also. Clear? So, now we are going to discuss each and every question. Concentrate on a screen. We are going to discuss question number 2.1, and in this question we have to find some fill in the blanks. Clear? So, concentrate on a screen. In part number A, it is given to you the volume of a cube of side 1 centimeter is equal to in meter cube. Clear? So, now concentrate here. Now we can say, let's suppose this is cube. Let's suppose this is cube having side that is L. Clear? Because we are talking about cube, so we can say this L always remains same. This is also L and this one is also L. Clear? So if we talk about volume of a cube, clear? So volume of a cube, this is given by L cube. Clear? Volume of cube, this is given by L cube. Clear? So now we can say actually value of side is given to you in centimeter. This is 1 centimeter. So we can write like this. This is 1 centimeter whole cube. Clear? Or we can say this is equal to 1 centimeter cube. But here we have to find this volume in meter cube. So now we know very well, in 1 centimeter we have 10 to the power minus 2 meter. So we can write like this. This is 10 to the power minus 2 meter whole cube. Clear? So from here we can say this is equal to 10 to the power minus 6 meter cube. Clear? So what is correct answer? Correct answer we can say this is 10 to the power minus 6 meter cube. Clear to everyone? Clear? Now we are going to discuss part number B. In fill in the blanks B, it is given we have to find surface area of a solid cylinder of radius 2 centimeter and height 10 centimeter is equal to what? Clear? So let's suppose I am talking about this solid cylinder. Let's suppose this is solid cylinder. Clear? For this solid cylinder, radius that is given to you, and this is equal to 2 centimeter. Clear? And height is also given to you in this question, and value of height is 10 centimeter. So this value we have 10 centimeter. Clear? Now our objective here is to find surface area. Clear? So what is formula of surface area of this solid cylinder? I can say we can write like this. This is equal to 2 pi r square plus 2 pi r h. Clear? We can say this is what? We can say this is pi r square. This one is also pi r square. Clear? And if we are talking about chord surface area, this is equal to 2 pi r h. Clear? So surface area we can write like this, 2 pi r square plus 2 pi r h. Clear? So from here you can take here common 2 pi r, and we can write like this. This is r plus h. Clear? Now we can put here value of radius and height, and we can find surface area in centimeter square. Clear? So now concentrate. Yes. Now we can say we can write like this, surface area this is equal to 2 pi. I can say 3.14 multiply value of r. Value of r we have 2 centimeter, and this is 2 plus I can say that is 10. Clear? And we are getting this value in centimeter square. Clear? So from here we can write like this. This is 6.28 multiply 2 multiply 12, and this is in centimeter square. Our objective here is to find this value in mm square. Clear? So we can write like this. This is 24 multiply 6.28. Clear? And multiply in centimeter square. We can say we can write like this. This is 10 to the power minus 2 10 to the power minus 2 meter square. Clear? 10 to the power minus 2, and we can say this is meter square. Yes or no? 1 centimeter equal to 10 to the power minus 2 and meter, and we can write like this. This is here. This is square. Clear? So from here we can say this is equal to, if you multiply, actually you can multiply like this. First you can multiply with 12, so that the calculation always remains easy. Clear? Listen carefully. Again I am writing here this line. Clear? Yes, listen carefully. First you can multiply it with 2, clear, or you can multiply 6.28 with 12, clear. So we can write like this, 12 multiply 8, this is 96, I can say 6, we have 9, 24 and 9, we can say 33, we have 3, 12, 6, 72 and we have 3, 75.36, multiply 2 and this is in centimeter square. We can convert into meter square, yes, 10 to the power minus 2 meter and this one whole square, clear. So from here we can write like this, this is 12, we have 1, this is 7, we can say 10, here we have 1, so this is 150, clear. So 150.72 into 10 to the power minus 4 and this is meter square. But our objective here is to convert this value in mm square, clear. So how can we find in mm square? In mm square we can say 1 meter equal to what? That is 1000 mm, yes or no? So we can say this is equal to 150.72 into 10 to the power minus 4, 10 to the power, we can say 3 whole square, clear. So this is 10 to the power 6, clear, 10 to the power minus 4, so total we can say 10 to the power 2 or we can say it is multiplied with 100, clear. So we can say this is equal to 150.72 into 100 and this is in mm square, clear to everyone. So this is answer of part number B. Now we are going to discuss part number C. And in part number C, it is given to you a vehicle moving with the speed of 18 km per hour covers meter in 1 second. It means directly it is clear we have to convert this kilometer per hour into meter per second, clear. So how can we write here? Listen very carefully. How can we write here? Actually, how can we convert kilometer per hour into meter per second? You know very well, if we want to convert kilometer per hour in meter per second, we have to multiply it with 5 by 18. Clear to you? So directly we can say, actually this is very easy question. So we can say a vehicle moving with a speed of 80 km per hour covers in, so we can say speed. This is 18 km per hour. We can convert into meter per second and we have to multiply it with 5 by 18 and we can say this is 5 meter per second. It means I can say any vehicle is covering a distance of 5 meter in 1 second. Clear to everyone? Or you can say, sir, how can you multiplying this one? Clear? So directly you can say it is given here 18 km per hour. First, we can convert this kilometer into meter. We have to multiply it with 1000. Clear? And we can convert this hour into second if we multiply it with 60 into 60. Clear? So if you solve it, you will find here this is equal to 18 multiply 5 by 18. Clear? So from here we can say that vehicle is covering distance 5 meter in 1 second. Clear? So now we are going to discuss part number D. Part number D. In part number D, relative density of lead is given to you. This is 11.3 and now we have to find this density in gram per centimeter cube or kilogram per centimeter cube. Clear? So concentrate. Yes. Now you can say here relative density of lead. So actually we know formula of relative density. This is what? Density of substance. Density of substance. It is the ratio of actually density of substance to density of water. Density of substance to density of water, an important part here at 4 degrees Celsius. Clear? So if we talk about specific gravity of water at 4 degrees Celsius in CGS, clear? So I can say in CGS this value we have 1, clear? And if we are talking about in MKS, clear, or we can say in SI, this value we have that is 1000. This is for what? This is for water. Clear? So I can say density of a substance in gram per centimeter cube for lead. This is given by density for lead. This is given by S multiplied rho W. Clear? So I can say value of S. Value of S we have that is 11.3. 11.3 for what? We can say this is for lead. Clear? And actually this value is what? Yes, actually this value is given to you. This is we can say value of density of water. Clear? density of water in the CGS form, clear, and we can say in the MKS form, clear. So now if we want to convert into gram per centimeter cube, it means we will multiply it with 1, clear. So I can say, just now I can say in CGS we can write like this: density of lead, this is given by 11.3 gram per centimeter cube, clear. And if you are talking about density of lead in MKS, or we can say SI unit, at that time you can say this is given by 11.3 multiply 1000. Why I am multiplying with 1000? Because density of water in kilogram per meter cube we have 1000, clear. So now we can say this is equal to what? 11.3 into 10 to the power 3, and we can say this is kilogram per meter cube. Clear to everyone? So this is all about, actually you can write like this: this is 11.3, clear, and here we are having 11.3 into 10 to the power 3, clear. So this is all about this question. Now student, we are going to discuss question number 2.2, and in this question it is given to you: fill in the blanks by suitable conversion of units, clear. So first part is given to you. First part, A, 1 kilogram meter square per second square, this is equal to how many grams per second square and centimeter square, clear. So you can say in 1 kilogram we have 1000 gram, so we can write like this: this is 1 multiply 10 to the power 3 gram, clear. In 1 meter we have 100 centimeter, so this is 100 centimeter square, and second in CGS we always remain second, clear. So it is given here, so we can write like this: this is 10 to the power 3 multiply 10 to the power 4 gram centimeter square second power minus 2, clear. So from here we can write like this: this is 10 to the power 7 gram centimeter square second power minus 2, clear. So we can say here we are getting this answer 10 to the power 7, clear to everyone? Yes. Now now we are discuss part number B. In part number B it is given 1 meter equal to how many light years, clear. So actually we know 1 light year, this is equal to 9.46 into 10 to the power 15 meter, clear. So can we find here value of 1 meter? Yes, 1 meter is given by 1 upon 9.46 into 10 to the power 15 light year, clear. So from here you can say, if we are writing here 1 upon 9.46, so definitely we will find 0.1 something, clear. It means we will find this magnitude of this 1 meter, it will be equal to approximately 10 to the power minus 16 times of light year, clear. So from here you can say this is equal to nearly 10 to the power minus 16 light year, clear. Yes. Now if we talk about part number C. In part number C it is given to you 3 meter per centimeter square, and we have to convert in kilometer per r square, clear. So we can write like this: 3 meter per second square, clear. This is equal to 3 in kilometer. We can say 1 meter equal to 10 to the power minus 3 kilometer, clear, because we know 1 kilometer equal to what? 1 kilometer equal to 1000 meter, clear. So 1 meter equal to what? 10 to the power minus 3 kilometer, clear. And we can say, because this is s power minus 2 here, so we can write like this: this is 1 upon 60 into 60, this is r power minus 2, clear. I converted here second in r, clear. So now we can write like this: this is 3 into 10 to the power minus 3 multiply 1 upon, actually we can say, if you see here, this is power minus 2, clear. So we can write in terms of power 2, yes. So we can say this is 60 into 60 into 60 into 60, clear, clear. So from here you can see this is 3 into 10 to the power minus 3 into 36 into 36 into 10 to the power 4, clear. So from here you can say 36 multiply 36, 36 multiply 36, we can say this is 36, 18 18 again 36, here we have 9, clear. So from here we can write like this: this is 3 into, clear, 10 into 36 multiply 36, this is equal to, I can say 6, we have 9, and this is 12, clear. So from here if you multiplied 3 with 1296, at that time you can say, actually you can write like this: let's suppose this is 1300, clear. 1300 means we can say this is 3900 minus, if we multiply 4 with 3 we can say that is 12 multiply 10, clear. So this is equal to what, 3890 and 3888, 3888, clear, and it is multiplied with 10 and this is now converted into kilometer per hour square, clear, kilometer r power minus 2, clear. So this is all about part number C, clear. Now we are going to convert part number D, clear. So in part number D, in part number D actually value of universal gravitational constant is given to you, clear, and now we have to convert this into centimeter cube second square second power minus 2 and g power minus 1, clear. So now concentrate. Now in this question it is given to you in part number D, capital G we have 6.67 into 10 to the power minus 11, clear, and this value is given to you in Newton meter square per kilogram square. So first can we convert this unit into meter cube per second square per gram, yes or no? Yes. How can we convert? We can write like this, 6.67 into 10 to the power minus 11, this is Newton. Newton is a unit of force. We can write force equal to mass into acceleration. So this is kilogram meter per second square, clear, and we can say this is meter square divided by, I can say this is kilogram square. Yes, yes or no? We can say this is mass into acceleration, so we can say kilogram per meter square, kilogram meter per second square, this is meter square and this is kilogram square. From here this one and this one cancel out and we can say this is equal to 6.67 10 to the power minus 11, clear, and this is equal to meter cube per kilogram and this one is second square, clear. So now we can convert this into this unit, clear. So in 1 meter we have 1000 centimeter, so we can say this is 6.67 10 to the power minus 11 multiply, we can say this is, because 1 meter equal to 100 centimeter, so 10 to the power 6 divide by 1 kilogram we have 1000 gram, so 10 to the power 3 multiply, clear, this is second square, so this is second square, clear. So I can say this is centimeter cube, clear, and we can say this is in gram. So from here we can say this is 10 to the power 3, clear. So we can write like this, 6.67 into 10 to the power minus 8, clear, and what is unit? Unit is given to you, clear, this is centimeter cube, clear, per gram per centimeter square, clear. So correct answer we have 6.67 into 10 to the power minus 8, clear. Here we have this one 3.88, we can say 3888 into 10 and kilometer per hour square, clear. So this is all about this question. Now dear student, we are going to discuss question number 2.3, and in this question it is given to you a calorie is a unit of heat, or we can say this is energy in transit, and it equals about 4.2 joule, where 1 joule is equal to 1 kilogram meter square per second square. Fine. Suppose we employ a system of unit in which the unit of mass equal to alpha kilogram, the unit of length equals beta meter, and the unit of time is gamma second. Fine. Now we have to show a calorie has a magnitude of 4.2, alpha power minus 1, beta power minus 2 and gamma square in terms of new unit, clear. So actually you can see here in all unit a calorie is defined in terms of joule, clear, and joule is equal to 1 kilogram meter square per second square. Actually, do you know one relation? Whenever we are talking about unit and its magnitude, you know very well we have one relation that NU, this value should be constant, clear. NU means we can say that product of magnitude and the unit, it always remains constant. For example, if I am talking about mass, let's suppose I am talking about 5 kilogram, clear. So let's suppose we have 5 kilogram and we have 5000 gram, clear. So definitely we can say 5000 is more compared to 5, but if we are talking about unit, definitely kilogram is more or larger unit compared to gram, clear. So if I are talking about product, this product always remains constant, clear. So from here we can say, we can write like this, N1 U1, this should be equal to N2 U2, clear. our objective in this question is to find value of N2. So we can write like this, N2, this is given by N1, I can say U1 divided by U2, clear. So in all we can say units, value of calorie, it is given to you 4.2 joule, clear. It means I can say this is 4.2 joule, clear. Here we write first unit of energy, clear. So for that one you need dimensional formula, clear. So if I talk about energy is having same dimensional formula as work, clear. Now work is defined as what? Work is defined as force, and this is defined as force multiplied displacement. So I can say force means mass into acceleration m1 l1 t minus 2, clear. m1 l1 t minus 2, this is force, and what about displacement? I can say that is l1, clear. So from here we can write like this, m1 l2 t minus 2, clear. m1 l2 t minus 2. Now you can write like this here, m1 by m2 power, what is dimension here? Dimension is 1, so this is 1, clear. I can say L, so this is L1 by L2, and it is also power 2, and this is T1 by T2, and this is power minus 2, clear. So from here we can write like this, this is 4.2, and here we have 1 joule, joule is equal to 1 kilogram, I can say this is 1 kilogram, but what about M2? M2 is given to you, this is alpha kilogram, so I can say this is alpha kilogram power 1, clear. What about L1 and L2? L1 we can say it is given to you that is meter, so this is 1 meter, and divided by what about L2? L2 is given, this is equal to beta meter, so beta meter power 2, and what about time? Time is given to you in second, so this is 1 second, and I can say this is gamma second in the new units, and it is power minus 2, clear. So now from here you can say this one cancelled out, this one is also cancelled out, this is cancelled out, clear. So what is we can say what is magnitude of this calorie in new system of units? It is given by N2 equal to 4.2, clear, 4.2 alpha power minus 1, I can say this is beta power minus 2, clear, and I can say this is gamma power 2, clear to you? Yes, so I can say this is value of magnitude, clear. So we have to show that relation only, that a calorie has magnitude of this one, clear. So this is all about this question, clear. Now student, we are going to discuss this question number 2.4, and in this question it is given to you, explain this statement clearly, okay. And what is this statement? To call a dimensional quantity large or small is meaningless without specifying a standard for comparison, correct. Let's suppose I have this stylus and I want to measure length of this stylus. Definitely I need a meter scale, clear, or I can say centimeter scale, clear. It means I need a reference. Let's suppose if I say this stylus, the length of this stylus is very large, clear. Now this statement itself is meaningless. Why? Because if we are talking about length of this stylus, then I have to compare it with someone else, clear. So let's suppose if I am talking about, yes, the length of this stylus, it is actually very large compared to length of an insect, clear. So this statement is meaningful, clear. So what is this statement saying to you? That to call a dimensional quantity large or small, that we have to specify here a standard for comparison, clear to you. Now actually now here total 6 statements are given to us, and we have to reframe the following statement whenever necessary, clear. So number 1, if I am talking about atoms are very small object. Now this is a meaningless statement. Why? Because if we are talking about size of an atom, then we have to compare it with another object, yes or no. So actually how can we say, how can we reconstruct this statement? Atoms are very small object compared to tip of iron nail. Now you can say this is complete statement, clear to you. Now if we talk about part number B, a jet plane move with great speed. Now again this is incomplete statement. Why? We have to write here like this, a jet plane move with greater speed compared to speed of a train, compared to speed of a train. Clear to everyone? Yes. Now if I talk about part number C, the mass of Jupiter is very large. We are talking about mass of a Jupiter. With what comparison? So actually we can actually reframe this statement like this: the mass of Jupiter is very large compared to mass of Earth, compared to mass of Earth. Clear? Now this is complete statement. Clear? We can say here the air inside this room contains a large number of molecules. Now again we have, this is incomplete statement. We will write it like this. Number D. The air inside this room contains a large number of molecules, compared to 1 mole of air, inside the room. Clear? Actually whenever you are discussing about certain thing, clear, you have to compare with another thing. Clear? So actually we are talking about number of molecules, large number of molecules, compare it to 1 mole or number of molecules in 1 mole of air. Clear? So now we can say this statement is complete. Number 5th, a proton is much more massive than an electron. Now this is complete statement. Clear? Because we are comparing here mass of a proton with mass of an electron. Clear? So I can say this is complete statement. There is no need of any modification. Clear? Now if I am talking about part number F, the speed of sound is much smaller than the speed of light. Absolutely true. Clear? So again I can say this statement is absolutely true, no need of any modification. Clear? That's why in this question it is written here whenever necessary. Clear to everyone? So this is all about this question. Dear student, we are going to discuss question number 2.5, and in this question it is given to you a new unit of length is chosen such that speed of light in a vacuum is unity. Clear? So it is given in this question, speed of light in vacuum, this is equal to unity. Unity means we can say this is equal to 1, or we can also write like this: 1 new unit of length per second. Clear? Actually we know speed of light in a vacuum, this is given by 3 into 10 to the power 8 meter per second. Clear? But here it is given here, we have to take speed of light in vacuum, this is equal to 1 unit. Clear? So now we can find here distance covered by this light like this. Clear? Our objective is what? Our objective here, what is the distance between sun and the earth in terms of new unit of light takes 8 minutes 20 seconds to cover this distance. Clear? So we can write like the distance covered by light, this is given by speed multiplied with time. Clear? Now what is value of speed? Speed we can say this is equal to 1 new unit of length per second. Clear? And it is multiplied with time. Time is given to you what? Time is given 8 minutes 20 seconds. Clear? So 8 minutes means what? 480 seconds. So total we have 500 seconds. Clear? So from here we can see second and second, this one is cancelled out. So we can write like this, this is equal to 500 times of new unit of length. Clear? So this is all about this question. Clear to everyone? Now dear student, we are going to discuss this question number 2.6, and in this question it is given to you, which of the following is the most precise device for measuring length? Clear? So actually 3 devices are given to you. Number 1 we have vernier caliper, second one we have screw gauge, and third one we have optical instrument. Clear? So actually we can measure any length by using meter scale or the centimeter scale, but let's suppose if we want to find any measurement that is precise from the centimeter scale, at that time we need vernier caliper. If we need more precise data, at that time we use screw gauge. Clear? And here it is given to you that if we want to measure the length and we need a most precise instrument, which one we used. Clear? So now concentrate here. So in the part number A, it is given to you a vernier caliper with 20 divisions on the sliding scale. Clear? A vernier calipers with 20 division on sliding scale. So let's suppose I am taking for vernier caliper 1 MSD. 1 MSD means 1 main scale division. This is equal to what? 1 mm. We know very well. Clear? In 1 centimeter scale, we have total 10 division. If we divide 1 by 10, we will find 0.1 centimeter, and that is equal to, we can see this is equal to 1 mm. Clear? So from here we can say, let's suppose, if nothing is given, I am just assuming, let's suppose 20 vernier scale division, actually this is coinciding with 19th main scale division. Clear? So from here we can find least count of vernier caliper. Vernier caliper. Clear? Vernier caliper. So least count of vernier caliper, this is given by 1 MSD minus 1 VSD. Clear? So 1 MSD, I am writing here only 1 MSD minus, I can say this is 19 by 20 and this is MSD. Clear? I can put value of 1 VSD from here, 19 by 20 multiply MSD. So from here we can write like this, 1 MSD, this is equal to 1 minus 19 by 20. Clear? So from here we can write like this, least count. So least count, this is given by 1 MSD. Clear? And this is 1 by 20. Clear? Value of 1 MSD we have, this is 0.1 centimeter. So 0.1 by 20. So 0.01 divided by 2. I can say 0.005. Clear? 0.005 centimeter. So this is what? This is least count of this instrument. Clear? Okay. So from here we can see this is least count of this instrument. It is clear to us? Fine. Now can we find here least count of this screw gauge? Clear? In part number B, it is given a screw gauge is having pitch 1 mm and having 100 division on circular scale. Clear? So how can we define least count of screw gauge? Clear? It is defined by pitch divided by number of division on circular scale. Clear? Now pitch is given here, this is equal to 1 mm. So this is equal to 1 mm and it is divided by number of division, we can say this is equal to 100. Clear? So from here we can see 1 mm. 1 mm is equal to 0.1 centimeter. So 0.001 centimeter. Clear to everyone? Clear? Now you can say if we compare A and B, definitely least count is least for screw gauge. So if we compare vernier caliper and screw gauge, means we can say screw gauge is more precise compared to vernier caliper. Clear? But we have to check here option number C also. So if we talk about option number C, if we talk about option number C, now an optical instrument can measure length to within a wavelength of light. Now you know that if we talk about visible range, so wavelength is like from 400 angstrom to 400 nanometer to 700 nanometer. Clear? Or you can say range of wavelength. Range of wavelength for visible range, this is given by 4000 angstrom to near about 8000 angstrom. Or if you follow NCERT, you can say this is 7500 angstrom. Clear? So from here you can write like this, 4000 into 10 to the power minus 10. Let's suppose if we are taking the longest wavelength. Clear? So actually this is smallest wavelength. Clear? So now from here we can see, from here we can write this is in meter. Clear? So 4 into 10 to the power minus 7 meter. Clear? Or we can also write like this is 0.4 into 10 to the power minus 6 meter. Clear? Can we convert it into centimeter? Yes or no? Yes or no? Yes, so from here we can see we can write like this, 0.4 into 1 meter equal to 100 centimeter. So this is 10 to the power minus 4 centimeter. Clear? So from here we can write like the 0.00004. Clear? And in we can say in centimeter. So from here you can say that if we are measuring length by using optical instrument, the value of least count or the value of least count is very small. Clear? So if I say, if we talk about vernier caliper, screw gauge and optical instrument, definitely I will say to you that most precise instrument to measure length, it is an optical instrument. Clear? So we can say this is all about this question. Now student, we are going to discuss question number 2.7. In this question it is given to you, a student measures the thickness of a human hair by looking at it through a microscope of magnification 100. Fine. He makes 20 observations and find that the average width of the hair in the field of view of microscope is 3.5 mm. What is the estimate on the thickness of the hair? Clear? So actually my dear student, actually here we are having one term that is known as magnification. Clear? And magnification. This magnification is actually defined as, according to this situation, that is observed thickness of hair to the actual thickness of hair. Clear? Actual thickness of hair. You can understand it like this. Let's suppose actual length of this stylus is 7 centimeter. Let's suppose, and let's suppose we are observing with the magnification of 4. At the time, length of this stylus we will observe that is 28 centimeter. Clear? So 28 centimeter is actually observed length of this stylus. 7 centimeter is actual length of this stylus. At that time I can say 28 divided by 7, I can say we are having magnification of 4. Clear? Similarly we can say in this question it is given we are actually measuring thickness of a human hair and magnification is given to you, this is 100, and observed thickness of hair we are taking here 20 observation, and if we are finding average value of this thickness we are getting this is 3.5 mm. Clear? So from here we can say this is 3.5 mm. So we can say this is in meter and divided by. Now our objective in this question is to calculate estimate the thickness, it means actual thickness of hair. Clear? So I can write like this, this is actual thickness. Clear? So how can we calculate this value? We can say, let's suppose I am representing it by a term that is small d. So small d, this is given by 3.5 into 10 to the power minus 3 divided by 100. Clear? So from here we can see this is equal to 3.5 into 10 to the power minus 5. Clear? This is in meter. Clear? We can also convert into mm also. Clear? So you can also write like this, this is equal to 3.5 into 10 to the power minus 2 mm. Clear? Or we can say this is equal to 0.035 mm. Clear to everyone? Clear? So now we can see actually this is actual thickness of the hair. Clear? So like this we can solve this question. Clear? Now student, we are going to discuss question number 2.8, and in this question again we have 3 part, or we can say ABC part. Clear? Now we have to give here answer of the following questions. Number A part, you are given a thread and a meter scale, and how will you estimate the diameter of thread? Clear? So let's suppose you have a thread and you have meter scale also. Now how can you measure diameter of that thread? Clear? So again a very simple logic you can apply here. Let's suppose you are taking this is a meter scale. Clear? Let's suppose I am taking this is a meter scale. Clear? Let's suppose this is meter scale, and let's suppose here we are having this thread, and let's suppose you are actually wrapping this thread on this meter scale like this. Clear? And this actually we can say you are actually forming a number of turns of this thread, and these threads are very close to each other. Clear? It means you can say in two turn you are having a negligible spacing, clear. So let's suppose I am saying this length is L, clear, and let's suppose I am saying here we have total and number of turns. So let's suppose if I want to find this thickness, clear. So if I want to find this thickness, it means how can I find? I can find like this. This is L by N, clear. Total length I can measure from meter scale, and we can count total number of turns, clear. And if we divide total length by number of turns, at the time we can find the thickness of this thread, clear. And thickness of this thread is actually what? That is diameter of this thread, clear to everyone. So this is answer of part number A. Now if we discuss about part number B, in part number B it is given to you a screw gauge has a pitch of 1 mm and 200 division on circular scale, clear. Okay, fine. Do you think it is possible to increase the accuracy of screw gauge arbitrarily by increasing the number of divisions on circular scale, clear. So now you can see we can find actually list count. List count of a screw gauge. This is given by pitch upon, I can say, number of division on circular scale. Number of division on circular scale. Number of division on circular scale. Clear to everyone? So now you can say generally it is observed if we increase number of division on a circular scale, list count becomes less, and when value of list count is less, it means that instrument becomes more precise. But actually we have again limitation in our eyes, clear. Actually if we talk about optical resolution, our eyes is having a specific optical resolution. We can see a particular object only, clear. It means what I am saying to you, if we increase total number of division on a circular scale, at that time it is very difficult for us to read reading on this circular scale, clear. So actually we have a limitation, we can increase number of division up to a certain extent only, clear. So now what is this question? Yes, it is possible. Yes, definitely if you increase number of division, definitely I can say yes, if it, we can say accuracy, or we can say list count decreases and we can say precision increases. But actually if we increase number of division on a circular scale, at that time it is very difficult to reading on circular scale. So again we have a limitation, clear. So that's why we can say yes, we can increase number of division but up to a certain extent only, clear. Now we are going to discuss part number C. So in part number C it is given the mean diameter of a thin brass rod is to be measured by vernier caliper, clear. Y is a set of 100 measurement of diameter expected to yield a more reliable estimate than a set of 5 measurement only, clear. So actually we can see if we increase total number of measurements, clear, and if we find here average value, so that average value you are getting, that is very near to the true value of the true value, clear. Let's suppose you are measuring length of this stylus. Again I am taking this example, clear. So let's suppose I am taking this, if I am measuring here length of this stylus, and let's suppose this length is come out to be 7 cm, clear. Again let's suppose I am taking here 10 readings, clear. 7 cm, 7.1, 6.9, 6.8, 7.2, 7.3, like this, clear. And if I take here average, then my value it will be come out to be very close to actual value, clear. Let's suppose its actual value will be 7.1 cm, clear. So whenever I will find here average, my value will come out to be very near to 7.1 cm, clear. And if I increase number of observation, it is a very certain probability that average will come out to be very close to actual value, clear, or true value, clear. So I can say yes, definitely if you increase number of measurement, definitely precision increases, clear. So this is all about this question, clear. Now student, we are going to discuss this question number 2.9, and in this question it is given to you the photograph of a house occupy an area of 1.75 cm. So we can write here area this is equal to 1.75 centimeter square, and this is equal to 1.75 into 10 to the power minus 4 meter square. Clear to everyone? On a 35 mm slide, fine. The slide is projected onto a screen and the area of the house on the screen is 1.5 meter square. So we can see this is actual. This is area of actual object, and we can say this is projected area. Clear? So projected area, it is given to you 1.55 mm square. Clear? Now what is our objective? Our objective here is to find what is the linear magnification of projector. Clear? Our objective here is to find linear magnification. Clear? So linear magnification means first we will find here magnification, that is aerial magnification, because in this question it is given here projected area and the actual area. So how can we write? We can write here this area projected to the actual area of an object. Clear? So from here you can see area projected we have 1.55 meter square, and actual area we can write like this 1.75 into 10 to the power minus 4. So from here you can see 1.55 divided by 1.75. 1.75 we can say this is 7 by 4. Yes or no? 7 by 4 into 10 to the power minus 4. So if I multiplied here with 4, how can we write? This is, we can say 0 we have 2, 22 we have 2, 6.20. Clear? And it is divided by 7 and multiplied with 10 to the power 4. Clear? So from here we can say aerial magnification. Clear? I can say aerial magnification. Clear? It is given by 62 divided by 7 into 10 to the power 3. Clear? From here you can say this is 9 point, approximately you can say this is 9. Clear? So I am taking this is 91. Okay, I am just taking this is 90. Clear? Near about 90 we are getting this answer. So 90 into, I can say this is 100. Clear to you? Clear? So from here we can say if we find here linear magnification. So now you can say area is actually what? Length into breadth. Clear? At that time if I am finding linear magnification, it should be equal to under root of aerial magnification. Clear? So we can write like this. This is equal to this is what, 90. So we can say this is 90 into 100. So we can say this is equal to under root of 90 multiply 100. Clear? So we can say this is equal to, this is 90. Clear? Now we know 80. Let's suppose if we take 81, square root of 81 is 9. Clear? And square root of 100 is equal to 10. So definitely this is in between 9 and 10. Clear? So let's suppose I am taking this is 9.4 and multiplied with 10. Clear? So I can say here linear magnification I am getting 94. Clear? So this is approximate. Clear? Approximation we are taking here, and 94 linear magnification we are getting. Clear? So this is all about this question. Now student, we are going to discuss question number 2.10. Clear? In this question we have to find total number of significant figures that is present in this following. Clear? So now let us try to understand one by one. In the part number A, you can see here we are having 0 before non-zero digit. Clear? So directly you can say here we are having a significant figure, that is 1. Clear? If we talk about part number B, we can say here we are having 3 non-zero digits. Clear? And non-zero digits are considered as a significant. So this is actually representing order of this digits. Clear? So order of magnitude. So order of magnitude is not considered as a significant figure. So we can say this is 3. Clear? Again, if we talk about part number C, after decimal we are having 0. So number of significant figure, in this significant figure we will count that 0, and we can say we are having 4 significant figures. Clear? In this situation, again we have 4 significant figures. You can see part number E is the condition of trapped 0. Clear? Trapped 0, we can say actually this 0 lies between 2 non-zero digits. So again we can say number of significant figure we have 4, and in this case we are having 0 before non-zero digits. So we will not consider it as a significant. So again we can say total significant figure in part number F we have, that is 4. Clear? So actually you should keep some points about significant figure in your mind. Number 1, all non-zero digits are considered as a significant figure. Clear? The zeros that is coming before non-zero digits, you will not consider that zero as a significant figure. Clear? If zero is coming between two non-zero digits, that is considered as a trapped zero. Trapped zero is always considered as a significant figure. Clear? And if we are talking about decimal, if 0 is coming after decimal, or you can say and 0 is always considered as a significant. Clear? If you are getting 0 after decimal but before non-zero digits, you will not consider it as a significant figure. Clear? So if you keep all these points in your mind, definitely this answer will always be true for you. In significant figures, we also find here addition and the subtraction of two numbers. Clear? Multiplication and division of numbers also. Clear? So definitely this topic is very interesting one. So just revise all the steps or all the concept related to significant figure. Clear? So this is all about this question. Now student, we are going to discuss question number 2.11, and in this question it is given to you the length, breadth and thickness of a rectangular sheet of a metal are 4.234, 1.005 meter and 2.01 centimeter respectively. Fine. Give the area and volume of a sheet to correct significant figures. Clear? So now concentrate on a screen. Now value of L that is given to you in this question 4.234 meter. Fine. Value of breadth that is given to you 1.005 meter. Clear? And we can see value of H. Clear? Or we can see thickness. So you can take L, H. So H is given to you 2.01 centimeter. Always keep in mind you have to convert this into meter. So 2.01 into 10 to the power minus 2 meter, or you can say this is equal to 0.002. Yes or no? No. Clear? We can write like this. This is equal to 0.0201 and this is in meter. Clear to everyone? Yes or no? Yes. Now our objective here is to find area. So how can we write here area? Actually we are having rectangular sheet. Clear? This is very important. Clear? So what is meaning of area of rectangular sheet? Clear? Let's suppose I am saying this is rectangular sheet, this one, this is rectangular sheet. Clear? In this sheet it is given to you, here we are having length L. Clear? This value we have, that is B, and this value is given to you, that is H. Clear? So directly if you find volume, you can say this is LBH. Clear? So area volume is LBH, but what about area? Area is given by 2 times of LB plus BH plus HL. Clear? It means we can write like this. This is equal to 2 multiply value of L 4.234 multiply 1.005 plus what is value of B? Value of B 1.005 multiply 0.0201 plus. Clear? Value of HL. H is given to you 0.0201 multiply 4.234. Clear? So from here now directly we have to multiply it here. Clear? So directly you can say, let's suppose I am taking 4.314 and 1.005. If you multiplied it, you can say this is 20, we have 2, 17, we have 1, 11, we have 1, this is 21. Clear? 0, 0, 0, 0. Clear? Now we can say again 0, 0, 0, 0. Clear? Now if you multiply it with 1, you can say that is 4, 3, 2 and again 4. Clear? So from here you can say this is 0, 7, 1, 5, 5, 2, 4. Clear? Now total number of decimal 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Clear? This one. It means 4.255170. Clear? I am writing here. This is equal to 2 times of 4.255170. Now dear student, here exact calculation is required because we have to find this answer up to a correct significant figures. Clear? Now we have to multiply 1.005 into 0.0201. Clear? So now concentrate. Yes. Now from here you can see if we multiply 1.005 with 0.0201, clear, 0.0201, 0.0201, okay, fine. So directly you can say actually this is after decimal we have 1 2 3 4, here we have only 3, so we are taking only 3, clear, we are taking here 3 only, clear, yes. Clear, this is 2.01 centimeter, we can say we can divide by 100, so 0.020, clear, I am taking up to 3 only, clear, yes. So now from here we can see we can write like this here. First we can write here, this is only up, we are taking up to this one only, clear, yes. So if I multiply it here, just a minute, this one, clear. Now listen carefully, if you multiply 1.005 with 0.020, then we can say 0 0 0 0, clear, we have here 0 1, clear, then 0, then 2, clear, clear, then we can say again 0 0 0 0, clear, and you can say 0 0 0 0, clear, this one was again 0, clear. So from here you can say 0 0 1 0 2 0 0, clear. If we talk about decimal point 1 2 3 4 5 6, 1 2 3 4 5 6, this one, clear, it means we are getting this value, this is equal to 0.0201, clear, this one, clear, 201 and 00 plus. Now we have to multiply here this one also, clear, so we can write like this, this is 4.234, clear, and multiply it with 20 divided by 1000, we can also write like this, we can say this is also 1000, this one and this one cancelled out. If you multiply it with 2, you can see this is 8, we have 6, this is 4, this is 8, divide by 10 to the power 5, clear. So we can say this is equal to 0. And this is 0.08468, clear. Now we have to add all these values, and after that we will get this answer, clear. So now we can say this is equal to 2 times, first we are adding all these 3 terms, clear. So now concentrate. Yes, definitely calculations are little bit lengthy, but if we want to find here exact answer, definitely we have to do some calculation, clear, yes. Now listen, we can see actually here we are having 4.255170, clear, this is after decimal 1 2 3 4 5 6, clear, 1 2 3 4 5 6, clear, and 1 2 3 4 5 only, so 0.08468, clear. Now we have to add all these 3 terms, so 0, we have 15 1, so 2 3, and this is 9, this one is 9, 5 2 7 8 15, we have 1 3, and this is 4, clear. So finally we are getting 4.35995, clear. Now we have to multiply it with 2 only, clear, this is equal to 0, clear, again we have 10, we have 1, 18, we have 19, we have 1, 19, 18, again we have 19, we have 1, 5 to 10, we have 11, we have 1, 6, 7, clear, and we can say that is 8, clear, but we need here answer up in a significant figure. So now you can see after decimal we are having 3 significant 3 digits, clear, after decimal we are having 3 digits, and in this we are having after decimal that is 4 digits, yes or no. It means actually we will take total number of significant figure in result according to minimum number of digits after decimal. So minimum number of digits we have 3 only, so correct answer for area, correct answer for area we will take up to 3rd digit, clear, after decimal. So we can say 719, so actually this digit 9, this 9 is actually we are confident, but this 9 is doubtful, so we will drop this 9, clear, because this is greater than 5, clear. So we can increase this one by one amount, clear. So when we increase this become 10 and this become 2, so finally we are getting 8.720, clear, and this is in meter square, clear. So I can say this is area, clear. Similarly we can find here volume also, clear. So concentrate here for volume. Now we know volume is given by LBH, clear. Value of length we have 4.234 multiply, clear. If we are talking about B is 1.005 multiply, clear, multiply. We can say this is 0.0201, clear. Now just apply some intelligence. You have already multiplied this one, clear, where this one 4.234 into 1.005, so we can say this is equal to 4.255, clear, and 170, it is multiplied with 0.020, let's suppose, clear. So we can write like this is equal to 1000, clear, and we can see this is equal to 1 2 3 4 5 6 10 to the power 6, this one and this one cancelled out, clear. You can directly first multiply, clear, this one is, and this one also cancelled out. So multiply it, 2 multiply 7, this is 14, we have 1, this one is 3, we can say 10, just a minute, clear. 2 multiply 7, 14, we have 1, this is 3, clear, and we can say 5 multiply 2, this is 10, we have 1, so 11 we have 1, this is 5, and we can say that is 8, clear, and it is divided by 10 to the power 7, clear. So now what is our objective? Our objective here is to find this volume in terms of significant figure, clear. So now we can say in multiplication we always find significant figures according to that number in which we have less number of significant figure. Here we have 4, here we have 4, and here we have 5, clear. So actually we can say here we are having only 3 significant figure, because all the zeros before we can say these are the non-significant, clear, and here we are having 4 significant figure, 4, and here we are having only 3. So we will write this result up to 3 significant figures only, clear. So we can say, we can write like this, 851034 into 10 to the power minus 7, clear. Now we can also write like this, this is 8.51034 into 10 to the power minus 2, clear. We are dividing by 10 to the power 5 and multiplying with 10 to the power 5, clear. Now we know order of magnitude, it will not consider as a significant. I can say we need only up to 3 significant figure only. So the answer will be 0.0851,034, clear, and this is in meter cube. Now we have to write this answer in terms of significant figures. So now you can say here we have 3 significant figure, we have 4, so we will write here only 3 significant figure only. So directly you can say we will drop this 0 and all other terms after it, clear. So correct answer we have 0.0851 meter cube, clear. So this is all about this question. Now student, we are going to discuss this question number 2.12. In this question it is given to you the mass of a box measured by a grosser balance is 2.30 kilogram, fine. And so let's suppose I am taking here, this is box, clear, this is box, and mass of this total box is given to you 2.30 kilogram, clear. Again here it is given 2 gold pieces of masses. So let's suppose this is piece number 1, this is piece number 2, clear. 2 masses are given, this is equal to M1, this is equal to M2, clear, and definitely values are given to you. Now we have to find first total mass of a box. So total mass, we can see total mass, this is given by capital M plus M1 plus M2, clear. So capital M is given 2.30 kilogram, clear, plus. Now we have to convert first these masses in gram into kilogram, clear. So we can write like this, this is 0.02015, clear, plus 0.02017, and we convert all the masses in kilogram, clear. Now we will add. So if you add it, we can see 2.3, clear, 2.3, then we can see this is 0 0, so this is 3 only, 2 to 4, clear, then we can say that is 0 0, then 2, and we can say 7 and 5, this is 12, so this is 12 and this is 3, clear. Now we can say whenever we are adding, we always find the least number of digits after decimal. So here we are having only 2 digits, clear, after decimal. So we will find here, we will write here final answer according to this one. We will write only 2 digits after decimal, clear. So now you can see here we are having, we are actually certain up to this digit, but we are uncertain about 0, clear. So before 0 actually we have what, even number, so we will write only this term. So correct answer we have 2.34 kg is the mass of this box, clear to everyone? Yes. Now if we talk about the difference in the masses of two P's to be correct significant figure, clear. So if I find here delta M, we can see this is M2 minus M1, clear. M2 value is given to you, this is 0.02017 minus 0.02015, clear, yes or no? Yes. So from here we can see, we can write here answer. Okay, actually you can also write directly like this, 20.17 minus 20.15, because you are subtracting gram from gram, clear. So from here we can write like this, 0.02 gram, clear. Now whenever we are talking about subtraction after decimal, we have only 2 digits, here we have 2 digits. So in final answer again we will find only 2 digits after decimal, clear. So correct answer of this question, we are having difference in the masses, this is equal to 0.02 gram, clear. So this is all about this question. We are going to discuss question number 2.13, and in this question it is given to you a physical quantity P is related to 4 observable A, B, C and D as follows, clear. Value of P is given to you A cube B square divided by under root of C D, clear. So first I am writing this expression P is given to you A cube B square divided by under root C and multiplied with D, clear. A cube multiply B square divided by under root C multiply D, fine. The percentage errors in the measurement of A, B, C and D, it is given to you 1%, 3%, 4% and 2%, clear. So now we have to find what is percentage error in the value of P, clear. So we can write like this, percentage error in P, this is equal to, or we can write like this directly, actually you know the expression, how can we find error. So delta P by P multiply 100, this is equal to 3 times of delta A by A multiply 100, clear, plus 2 times of delta B by B multiply 100, clear, plus 1 by 2 delta C by C multiply 100 plus delta D by D multiply 100. Always keep in mind, whenever we are calculating errors, error is always added, clear. We will not subtract error at any instant, clear. So we always find error and error is added, always keep in mind. So our objective here is to find percentage error in the value of P. So how can we find? We can directly write like this, 3 multiply percentage error in A. Percentage error in A is given to you 1, clear, plus percentage error in B, that is 3%, so 2 multiply 3, plus percentage error in C, half multiply 4, clear, plus percentage error in D, this value we have 2, clear. So from here we can say this is equal to 3 plus 6 plus 2 plus 2, clear. So this is equal to what? 3 plus 6 9, 9 to 11, 11 to 13. So total percentage error we have 13%, clear. Percentage error in the value of P, this is equal to 13%, clear to everyone, clear. Now our objective, okay, one objective is completed. If the value of P calculated using above relation is turned out to be 3.763, clear. Now we have to find to what value should you round off the result, clear. Now listen carefully. If we are talking about 13%, then 13% we can say this is 0.13. In 0.13 we are having 2 significant figure, yes or no? So whenever we have 2 significant figure, we will convert this result into 2 significant figures only, clear. So now we can say we are confident up to 2nd digit, but we are not confident about this 3rd digit. This 3rd digit is actually greater than 5. It means definitely here we will increase first, and whenever we are doing round off, so at that time we will actually write this value as a 3.8 and according to correct significant figures. Clear? So this is all about this question. Now dear student, we are going to discuss this question number 2.14, and in this question it is given to you a book with many printing errors contains 4 different formulas for the displacement y of the particle undergoing a certain periodic motion. Now we have to rule out the wrong formula on dimensional ground. Clear? Now concentrate. Now in this situation A, B, C and D, clear? You can see if we are talking about left hand side, in left hand side we are having only y. Y means we are having dimension only for length. Clear? Because it is given here, actually this is related to displacement. Clear? So m0, l0, t0. Clear? And if we talk about dimensional analysis, the left hand side should be equal to the unit of the dimensional formula of left hand side should be equal to dimensional formula of right hand side. Clear? So first we check here number A. In number A it is given y equal to a sine of 2 pi t divided by capital T. This A is actually, we can say this is amplitude or maximum displacement. Clear? Maximum displacement. Clear? Displacement. Now you know very well, whatever if we are talking about plane angles, in plane angles we are having dimensional formula m0, l0, t0. Clear? So now we can say this 2 pi, this 2 pi is what? 2 pi is constant, this t is what? That is time, and this t is also time period. Clear? It means I can say here we are having dimensional formula m0, l0, t0. Clear? And because this is displacement, so we can say right hand side dimensional formula m0, l0, t0. Clear? It means I can say this relation that is given in that book that is correct. Clear to everyone? Now if we are checking here number B, in number B it is given a sine, if we are talking about y equal to a sine Vt. So Vt means we can say that is meter per second. Clear? And T means we can say that is only second. This is unit. Clear? So if I write here dimensional formula, clear? Dimensional formula inside this bracket. Clear? Dimensional formula for this one I can write like this. This is L1 T minus 1 and this is only T1. Clear? I can say this one and this one cancel out, but inside this sign we always having dimensional formula m0, l0, t0. Clear? It means definitely this relation is wrong. Clear? According to dimensional analysis. Clear? Now if I am talking about part number C, in part number C it is given y equal to alpha divided by t. Clear? Sine of t by a. Clear? Again you can see in this sine term again we have m0, l0, t0 dimensional formula, but here we are having dimension that is L minus 1 and T1. How? Because this is T represent time, so this is the T1, and A represent amplitude, so this is L minus 1. Again we can say this is not dimensionless, it means C relation is also wrong. Clear? Now if I am talking about this is wrong, this one is also wrong. Now if I am talking about part number D, in part number D it is given y equal to a root 2. Clear? So first I am writing here a root 2, this is sine of 2 pi t divided by t plus cos of 2 pi t divided by capital T. Clear? So now we can say t is what? Time. Clear? And capital T is what? Time period. It means we can say this ratio will come out to be m0, l0, t0. Clear? And this is actually root 2. Root 2 is what? Dimensionless, and a is what? Having dimension L1. It means I can say option number, we can say this D part, this relation is also correct. Clear? So now we can say out of 4 relation, 2 is correct, 2 is wrong according to dimensional analysis. Clear? So this is all about this question. Now dear student, we are going to discuss question number 2.15. Clear? And in this question it is given to you a famous relation in physics relates moving mass m to the rest mass m0 of a particle in terms of its speed v and speed of light c. Clear? This relation first arose as a consequence of special relativity due to Albert Einstein. Okay, a boy recalls the relation almost correctly but forgets where to put the constant c. He writes expression like this. Clear? So what is this question? In this question it is given to you, actually we find one relation from Einstein relativity theory, and that relation is given by m is equal to m naught under root of 1 minus v square. Clear? So a student write this expression like this, and actually he forgot to write the expression of c in this relation. Now we have to find where we have to put that value of c. Clear? So now you can see, if we see from here dimensional analysis, in dimensional analysis we can see only same quantities, same nature of quantities are added or subtracted. Means now you can see here we are having one is what? Constant is what? It is dimensionless. Clear? So whenever we are subtracting any quantity from 1, it means that quantity is also, it should be dimensionless. Yes or no? It means I can write here like this, dimension of 1, this should be equal to dimension of v square divided by v dimension of v square. Clear? But you can see this v is what? This v is speed, and the dimension formula for this speed we have L t minus 1. Clear? So definitely you can say this is not equal to 1. So now we have to put here value of c. So where we can put this value? If we write this formula like this, m, this is equal to m naught upon under root of 1 minus v square upon c square. If we write like this, at that time you can see in numerator we have meter per second, in denominator we have meter per second. So definitely meter per second is cancelled out, and we are getting here dimensionless. Clear? So we can see this is correct expression. So if a student forgets to write expression of c, the expression of c, it will be written at this place. Clear? So this is all about this question. Clear? Now student, we are going to discuss this question number 2.16. In this question it is given to you, the unit of length convenient on the atomic scale is known as an angstrom, and it is denoted by A, and that is over a circle over A. Clear? 1 angstrom equal to 10 to the power minus 10 meter. The size of hydrogen atom, it is about 0.5 angstrom. What is the total atomic volume in total atomic volume in meter cube of a 1 mole of hydrogen atom? Clear? So my dear student, again a very simple question we have. So in this question it is given to you radius of hydrogen atom, and this should be equal to 0.5 angstrom. Clear? 0.5 angstrom. So we can write like this, R, this is equal to 0.5 multiply 10 to the power minus 10 meter. Clear? In this question it is given the size of hydrogen atom is given. Now we have to find total atomic volume of a 1 mole of hydrogen atom. So I can say what is volume of 1 hydrogen atom. Volume of 1 hydrogen atom. So from here we can write like this, this should be equal to 4 by 3 pi r cube. Clear? Let's suppose we are assuming, we can see this atom as a spherical one, so volume is given by 4 by 3 pi r cube. Clear? So can we find here volume of 1 mole of hydrogen atom, volume of 1 mole of hydrogen atom. Clear? And we can write it like this, this should be equal to Na multiply 4 by 3 pi r cube. Na is equal to what? Na equal to, we can say this is Avogadro number, because we know in 1 mole of a substance we have total number of atoms that is present equal to Avogadro number. So this is equal to Na multiply 4 by 3 pi r cube. Clear? So from here we can write this is volume Na. Na is equal to what? This is equal to 6.023 into 10 to the power 23 multiply. I can say this is equal to 4 by 3 pi, and this is r cube. Clear? So now we have to put here all values, and we have to calculate the volume of hydrogen atoms of 1 mole. Clear? So we can write like this: 6.023 into 10 to the power 23 multiply 4 by 3 multiply 3.14 into radius is given to you 0.5 into 10 to the power minus 10. I can say this is 1 by 8 into 10 to the power minus 30. Clear? So from here if you calculate, you can see this value is what? 2. Clear? Near about we are saying this is 3. Clear? And this one is cancelled out. Clear? So from here you can say approximate answer 3.14 multiply 10 to the power minus 7. Clear? 10 to the power minus 7, and this is in meter cube. Clear? So this is what? This is volume of a hydrogen atom of 1 mole of hydrogen. Clear? Clear? So this is answer of total atomic volume in meter cube of a 1 mole of hydrogen atom. Clear? So this is all about this question.